Alright, so we made this tree chart right here. And what we're going to look at is taking that tree chart and changing it back into a contingency table. Or if you might recall, these are actually called contingency tables. So the question is, what number could I put here? One thing to make your life easier is you can actually convert these to whole numbers. So if I had gone to the third significant digit right there, I would just say, oh, pretend I had 1,000 dice rolls. I'm going to go kind of nuts here since it works out. If I do 10,000 dice rolls, then I'll have nice whole numbers. Alright? So what number goes here? This means that I had a 20-sided die and I won. Alright, so how many rolls out of 10,000? Well, I can just take this 0.1225, right, and multiply it by 10,000, and I'll get basically this. That's why I chose 10,000. See, the probability of being a 20-sided and losing, well, this percent or this fraction was 20-sided and losing, so I'd multiply that by 10,000, and I get this number. By the way, since I know it's 10,000, I know this is my total right here. And if I add these two up, I should get 7,500. Alright. And finally, I can do this. Four-sided and winning, 1875. And four-sided and losing, 625. So it's kind of low there. And I'm going to get 7,000 here. And it looks like I will get 3,000 here. And if I add these across, I should get 2,500. So now you can actually, if I give you numbers, like I say, oh, a certain number of parts come from company A or percentage, you can convert them back. So there's another way you can look at this problem. Let's say, oh, this part. So if I gave you this basic same problem, so I'm going to use these numbers to set it up. But instead of you seeing the tree, this is how you see it in words. So in words, you say, oh, 75% of the die are 20-sided. Or die rolls, right? 20-sided. And you'd say 25%. I wouldn't even have to say the 25% are four-sided. I could just say the rest are four-sided. Alright, so 25% of the die rolls. Alright? And then I know the probability of winning here is the probability of winning for a 20-sided die is the 0.15, right? So what you could do is you could basically take this, and let me start with a big number like 1,000. So what you'll do is you'll say, okay, I know I have 20-sided die and four-sided die. And I've got wins and losses, and I'm going to have a total of 1,000 die, so if I have some decimals, it's okay. Alright? So I have 1,000 die total. Well, how many come from the 20,000 die? 750, because 75%. 250 here, right? Now I can go and take that 15% of 750 and apply it, and if I go 0.15 times, here, let me do this area, 0.15 times 750, right? How many rolls do I get? So I'll just do it on the calculator just to be safe. And I get 112.5. Now if you round here where it's at least 3 digits long, it's probably okay. I'm going to go ahead and do 0.5 because this was a theoretical anyways, and I'm not going to give them the actual number of rolls. So my decimal numbers are fine. Which means the rest of the 750 rolls were losses. It's 112.5, right? 750 minus 112.5 is 637.5. I'll pretend that's that. And then 250, a quarter of those win. So that's 62.5. Well, a quarter of those lose. Bad teacher. And 3/4 win. So 250 times 0.75 is 187.5. And then you can add down again to get these. It should look a lot like my numbers before. 187.5 plus 112.5 is 300. So that means this better add to 700, which it does. All right? So I can get the same table. So you can work with either the tree diagram from a theoretical where we just give you numbers and words, or you can go back and construct a table, whichever works better for you for figuring out conditional probabilities.